We can also give an example showing why union of two subgroups is not a subgroup, right? We have already discussed subgroups of Z, isn't it? What were they? Collection of nz which is equal to nk such that k belongs to Z. So this is actually collection of subgroups of Z. Why I am saying collection? Because for different values of n you will get different subgroups. Let us say if I fix my value of n to be 0, then this collection will be 0z, and 0z means actually nothing but singleton 0. If I fix my value of n is equal to, let us say, 1, then I will have 1z, and that is nothing but z again. If I fix my value of n as 2, then that is going to be 2z, isn't it? So 2z will be collection of what? So 2z will be collection of set of all 2k such that k belongs to z. We already know z is actually nothing but 0, 1, 2, 3 and so on. On negative side, -1, -2 and so on. So if I put my value of k here as 0, then I will get 0 as the element of 2z now, right? If I fix my value of k as 1, so 2 ones are, that is 2. Similarly, if I fix my value of k as 2, that will be 4. If I fix my value of k as 3, that will be 6, and this will be continued. I hope you can guess the rest of the elements. So 8, 10 and so on. What about on the negative side? So if I put my value of k as -1, so what I will get? -2, then this will be -4, right? Then this will be -6 and so on. So this is nothing but what? 2z. So similarly, if I put any value of n here, negative values also works. So if I put any value of n, let us say n is equal to 100, still we will be able to get a subgroup of z, and that is nothing but 100z, right? So similarly, can you guess what will be my 3z? 3z will be collection of, if you observe properly, 2z is a collection of multiples of 2 because 0, 2, 4, 6 and so on. So 3z will be collection of multiples of 3, right? And on the negative side, -3, -6, -9 and so on. Now notice these two are already subgroups of Z. But what about the union? So if I take 2z union 3z, then this will be a collection of, so 0 will definitely be there, and we know 2z union 3z will contain elements of 2z or elements of 3z, right? So first of all, let us think of elements of 2z. So 2z union 3z will contain multiples of 2 as well as it will contain multiples of 3, right? So 0, then I'll write 2, then I'll write this 3, then I'll write this 4, then I will write down this 6. Now I will not write this 6 because it is already written. So next element is 9, then next will be 10, right? Because 10 will be there in 2z and this will be continued. Similarly, on the negative side, I will have -2, then I will write -3, then I'll write -4, then I'll write -6 and this will be continued. So if you observe properly, this 2 and 3 are members of 2z union 3z, right? But what about the sum of 2 and 3, right? So sum of 2 and 3 is 5, but is 5 present in 2z union 3z? No, right? So which does not belongs to 2z union 3z. So what does it mean? It means that the set 2z union 3z is not closed under binary operation, right? So remember, in order to be a group, binary operation should be there, right? That set should be closed under the binary operation. Now, what is a binary operation in 2Z union 3Z? We are discussing subgroups of set, right? So in Z, plus is the binary operation. So with respect to plus, this set should be closed, meaning if you take any two elements, the sum should be also lie there, but this doesn't happen, and therefore this 2Z union 3Z is not actually a subgroup of Z.